Okay, so what I'm going to do is I'm going to draw the cliff. Okay, this is the cliff. Okay, and then there's a guy throwing a ball off a cliff, right? And he throws it horizontally. So here's my guy.
I knew that in a sense because I can use this formula because I have 4.
And he throws a ball off a cliff horizontally.
It's not going to take
Okay, and he throws it off with a velocity 4 meters per second that way. Quite a heavy rock, 3 kilograms. 3 kilograms is, but if it was smaller than that, it would be a stone, right? I think if it's bigger than a cat, it becomes a rock.
How big does a cat have to be?
Like an average cat. Anyway, right? At any point in this rock's motion, right, it has always got a horizontal velocity of 4 meters per second, and we're assuming there's no air resistance, right? And as it falls, it's gonna speed up in this direction. So this velocity is down. It's going to get faster and faster. So that velocity down is going to increase. Okay. So this velocity, the horizontal velocity here, is going to be constant, but this velocity is going to increase. Okay. Right. So question A says calculate the kinetic energy of the rock when it's thrown. So kinetic energy when it's thrown is just 1/2 mv squared, and the v is just the horizontal velocity, because it's just when it's thrown, it hasn't started falling yet. So this is going to be 1/2. The mass is what, 3 did we say? And v squared, so that's 4 squared. Okay, so this is going to be 1/2 times 3 times 16. So that's 8 times 3, right? 24. What are the units? Joules, because it's an energy, right? Okay. Now, after it's been thrown, the height of this cliff is what? Where did it say? 51 meters. Okay, so this stone is going to fall 51 meters. It says for part B, calculate the potential energy lost by the rock when it reaches the surface of the sea. So potential energy, just the potential energy it's lost. Okay. It's just going to be mgh, right? So this is going to be 3 times 9.8 times the height it's fallen, which is 51. I'm going to have to use my calculator, I think. So let's do that. 3 times 51. You got what, lad? 1,499.4. Yeah, joules. Yeah. Okay. 1,500 we'll keep there, yeah. That's pretty much what it is there. Okay, you happy with that then? So, initially at the start of the thing, we had this much energy. Yeah. The thing has fallen, this rock has fallen, and it has gained this energy, the potential energy. So initially we started off with 24 joules, it's fallen, and it's now got an extra 1,500 joules. So the kinetic, first of all, the question CI is asking for the kinetic energy when it hits the water, right? When it hits the water, is there any potential energy? No, because it's fallen, there's no height, right? So all of this energy from conservation of energy must have gone into kinetic, because we said that velocity is going to increase as it falls. Yeah, so kinetic energy, final, I'll put the final kinetic energy is just 24 joules plus all the energy it gained from falling.
No. Like
So I'm going to say that's one, that should be an equals, right?
brackets plus
1,524 joules. Yeah? Okay. Hence find the speed of the rock. Well, this is the bit that's worth the 4 marks. Hence find the speed of the rock. So to find the speed of the rock, well, when it hits the surface, when it hits the surface, it's got 2 components of velocity. Okay? So when it hits the surface, this stone is still moving horizontally at 4 meters per second. Do you agree with that? Okay. And it's also gained all this velocity from falling. V. Okay. We don't know what that V is. Okay. And if I want the speed, which is what it's asking for, the speed is the vector addition of those two, right? Okay. The magnitude of those two. So, how do I find out what that is? There. Any ideas? Where's this velocity come from? It's come from the potential energy, right? And that there was the potential energy we gained. So all this velocity, that's it, yeah. So this V here, just this bit here, half mv squared is equal to that much energy, because that's what was gained from falling, right? So I've got mv squared equals 3000, v squared equals, m was 3, right? So that's 1000. And so what's v?
If you think you can revise that, just 1 mark.
10 root 10, bro.
The 1 mark would be
Okay.
that
So now,
minus.
let's draw my picture again. I know that it's got a horizontal component of 4, a vertical component of 10 root 10,
That's really simple. But
and we want the magnitude, which is this bit here. That bit there is going to be the speed, right? Okay. So how do I calculate this? Speed.
this is where 14 comes into.
Real. The speed is going to be 4 squared plus 10 root 10 squared square rooted. Okay. Let's move that. So it's going to be 16 plus 1000 square rooted. Okay. Yeah. 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 What do we get first of all, and then we'll talk about that. 31.9.
Arc motors are